Hi guys, welcome to chapter 9. There's only one part to this. So chapter 9 we talk about single structures, arrays, and array name structures as and function arguments, right? So in this chapter 9 we'll talk about single structures, array of structures, and structures as function arguments. Basically, it's the idea of using a data type called structure. Okay. So structure is a data structure that stores different types of data under a single name. So a structure is a class that has no methods. All variables of class are public by default. And when we are creating and using structure, it requires basically two-step declaration and assigning the values, right? So let's look at a simple structure here, right? So a single structure like this would have the struct declaration, right? And in the struct declaration, it will have a bunch of members on its own, month, day, and year, right? And it can be called as a particular name, right? So it can be called birth. So the birth structure consists of three data items called struct members. So these three are the struct members. Right? So let me adjust that as right? So so it's very useful as we're gonna show it to you later, right? Right. So now so populating the structure or assigning data values to the data items of a structure, right, is just by using the dot operator, right? So it is easy to access the particular data there, right? So if we use birth.month, it will refer to the first member of the birth structure, right? So we have month, day, and year. So we can also have birth dot day, birth dot year, right, to access different data type in the structure, right? So again, this example, first we would declare it, right? So we declare a struct that's called birth, and it has members of month, day, and year, right? So we can have birth.month equals to 12, birth.day, and birth.year here, initialize values, and then we can simply access it here, right? So consider it as a collection of data type, right? So okay, so these are example of the output of the program earlier, right? So you can have multiple variables declared in the same statement. For example, earlier we have the struct name is called birth, but you can name different things, right? You can have birth, current, and a whole bunch of different variables that have the same data structures, right? Of month, and year, right? So they'll be identical in the types of variables that exist in the data structure in the struct, but it will keep their own values, right? So yeah, so that's one of the ideas. So you can have for example here we can have we can also have a global scope like this, struct date in here, right? So then we can redefine it by having date, birth, and current, right? So there's a slight difference here. Here we give it a struct. It's a local structure declaration, but we can have a global declaration where we give it a name for the struct, and then we kind of declare it with the with the variables that we want. So birth would have the type date, or we can have another one, maybe say current will have the birth type date, right? So you can define a few data structures that has the same members, right? The other idea here is to initialize the structure, right? They make it easy, and you can use a similar way as you define variable arrays, right? Sorry, not variables, arrays. So you can have date, birth, and initialize it straight away by these curly braces here. So the first element, the first member, second member, and the third member, right? All defined during the initialization, right? So individual members of the structure are not limited to just one data type. It can be any valid C++ data type, including both arrays and other structures, right? So let's say example here, we initialize and we start to so if we initialize it this way, we can remove these three lines over here, and essentially it'll do the same thing as the previous example, right? So one of the advantages of using structures is to create a list, right? A list of collected data, right? So I know we have talked about arrays, and we can actually implement this table here with an array, right? But there is some problems with that, right? We could for example here, process employee data in figure 6.1, we could represent the tables in an array. So we can represent employee number in one array, employee name in one array, and employee pay rate in one array. So we can access according to the element, and from the element we can either get the employee number, employee name, or the employee rate, right? Now, while this is doable, right, it can be a bit difficult, right, when we are trying to access and manipulate data, right? So that's option one. It is doable, right? And we can initialize it this way, but it is a bit confusing when we want to rewrite data and change data items, right? So structure gives you a better way to maintain the record and integrity of the data. So let's look at this, right? We can represent this as the first structure, second structure, third structure, fourth structure, and etc. And the best way to do this is basically to say struct pay record, for example, right? We have a ID number, string name, and the employee pay rate that we are using. So they have the ID number, have the name, and the pay rate that we're using. And then we create an array of struct pay record. So we have pay record employee, we call it a variable employee, that has 10 elements of it. So basically we're creating a array of struct with 3 members set, right? So now accessing this would be just by having the if we want the first employee, then we'll have employee 0 dot rate, and we'll refer to the this member here, right? So it gives a better idea in how we manage data in this table, and the integrity for the data is more maintained, right? So when we are declaring variables, we can it follows a structure. It follows the array notation. So you can also have curly braces and another curly braces, and all the data in one row, and the next row with another data with curly braces, and we finish it with the curly braces finishing it, right? So, and then we can just simply access it by looping through from 0 to the size of the array itself. All right. All right. So we'll stop here and have coffee. And I'll take a break, right? And we'll come back in a minute to continue with structures as a function argument, right? So see you in a bit.